Okay, here we are looking at question number 10, set 13, A and B. So in an experiment designed to determine the effect of acid rain on the pH of a small lake near a lead smelter, a researcher mixed equal volumes of water, one from the lake having a pH of 6.75 and the other from rainwater collected during a downpour having 5.1. Calculate the pH of the resulting mixture. Well, we need to really find for ourselves the concentration of H plus ions, and to do that we need to look at the two pHs. So once we've got the concentration, we can figure the number of ions, and we can find the final concentration by dividing by the final volume. So let's have a look. Number of H plus from pH, 6.75 is equal to 10 to the minus 6.75, and if we put that one through, we'll find that we'll have in 1 litre we'll have 1.778 times 10 to the minus 7 moles. That's just in 1 litre. Say 1 litre. Now notice this guy talked about using equal volumes there, so he didn't specify the amount of volumes. You just have to pick one arbitrarily to do. So let's use, seeing we're adding a litre of each, let's have a look at the amount of hydrogens of pH 5.1, and this is actually equal to 10 raised to the negative 5.1 moles per litre, which if you put through your calculator should give you oh dear, I've lost it here at this moment. Should give you a value of, let me just do that one, shift, find logarithm, find 10 to the x, minus 5.1, and you should get a value of 7.94.94328 times 10 to the minus 6. And that's how many moles in, say, 1 litre. Now you want to know the final concentration of hydrogen, and concentration is equal to the number of moles divided by the volume, as we've seen, which equals this number, 1.7783 times 10 to the minus 7 plus 7.94328 times 10 to the minus 6. Now all of those, that's the number of moles divided by 1 litre plus 1 litre. Okay, and if you do that, why we have to divide by 2? When you've added the a litre of each, equal volumes of each, you end up with 2 litres, so you've got to divide by that, which will come to, if you look at it, 8, which will give us a value of 4.061 times 10 to the minus 6 moles per litre. Now we just do pH, of course, is equal to negative logarithm of H plus, and when you put that number there through this, you find you end up with a number of 5.391, or actually, because it's to 3 figures, it's going to be 5.39, and that is how to do the A. Fairly straightforward. Now, part B, of course, is a bit more of a difficulty. It's got a trick to it. So when we're looking at this, we're the worker is adding equal volumes again. Sorry, go to the correct layer. He's adding equal volumes again of lake water and water of pH 8. So lake pH is equal to 6.75, we've known, and water that he's added equals pH 8.0. What you need to recognize with this is that the concentration of hydroxide ion here is going to be higher than the concentration of acid that is here. So what we need to do is we first need to figure out the concentration of hydroxide ion and subtract the acid from it. And that leaves us with a final concentration of hydroxide ion, which we can then come along and calculate the hydrogen ion concentration and then the pH. But again, we've got this equal volumes trick. Whatever we do, the number of moles from here subtracted the number of moles from here will have to be divided by 2 to get a concentration. So let's have a look at it. pH 6.75, the H plus concentration, really you can see that from the last one that you did, will give you 10 to the minus 6.75. Okay, looking across at that, the OH concentration of pH 8 is going to be equal to Kw divided by the hydrogen ion concentration, which is going to be 10 to the minus 14 divided by 10 to the minus 8, which is equal to 1 times 10 to the minus 6. Okay, so this is the concentration of OH minus ions. Now, OH minus are going to neutralize H plus plus OH minus to H2O. And it's a 1-to-1 ratio there. So we don't have to multiply it or scale it by anything. But we've added 2 together, so we've got 2 volumes. So our concentration is going to be equal to the the concentration of hydroxide remaining is going to be equal to the number of moles that we've added here minus the number of moles of hydroxide, hydrogen, sorry, and then divided by 2. So we've got 10 to the minus 6, subtract 10 to the minus 6.75, get the minuses in, will give us a concentration of 8.2217 times 10, what is it, to the minus 7 I think it is, moles in 2 litres. 1 litre from here and 1 litre from here. But that is no good in 2 litres. Molarity is in per litre, which will give us a value of 4.11086 times 10 to the minus 7 moles OH minus. Now, let me roll up a little bit more screen here. Need a bit more real estate, don't I? So H plus, as we know, equals Kw on OH minus, this is concentration, which equals 10 to the minus 14 divided by 4.11086 times 10 to the minus 7. Okay, when we actually do that particular number, we end up with something like, what is it, 2.432 times 10 to the minus 8. That's assuming I can read my handwriting correctly. That may be a 1 in front of 2. I'm not sure. You'll have to go back and check that. If we do the pH equals negative log of this number here, you'll find that you end up with a negative log of that should come out with a number of 7.61. And that's our pH of the two being added together. Notice the traps that we had in mind that you had to see when you're doing this. Hello, pen's not changing colour. Let me just change it for you. Notice the traps that we needed to do for that. Okay, we'll go with what we've got. Firstly, you need to make sure this is a bug in this particular software. Aha, now we're here. Okay, first thing that we needed to note, we've got 2 litres, not 1 when we add them together. Second thing that we need to note is that it's actually almost a limiting reagent. We take the smaller minus from the larger. So hydroxide concentration is larger. That has to subtract the hydrogen ion. And then you get back to the hydrogen ion of the remaining solution by going through this Kw expression. And that's how to do those two. I hope that's been of some help for you.